Okay, so what we need to review first is something called interval notation. You should have seen this in previous classes, but your answers in this section and many of the things we do this semester, I will ask for your answer in interval notation. So we just want to make sure that this is solid. It should be pretty straightforward. So interval notation. When you see something like this, in math, we're famous for the same thing can mean two different things in context. You know, it's like the words there and there. You listen to someone talk and you know what they mean, or if you see it written out, you know. 0, 10 could mean the point 0, 10, okay? But in interval notation, it means all the numbers between 0 and 10, but it does not include 0 and it does not include 10. Right here, where you see the brackets, that means all the numbers between 0 and 10, but what? Including 0 and including 10, okay? So that's the whole, you know, the whole lesson right there, just making sure you're solid with this. Now, what I've got is 3 columns here. These are all 3 ways to express the same thing. My goal is that you are very solid in interval notation, okay? So if I wrote a sentence, x is less than or equal to 7, how do you write this in math terms? You write x with these symbols. What do I write? X is what? Less than or equal to 7, okay? Now, on a number line, sometimes, and I don't ask for your answer to be number lines in this unit, but a number line can be a really good visual of what's going on. X is less than or equal to 7. Okay, I don't care where you pick it. Just pick a spot on that number line, call it 7, okay? On a number line, does this include the number 7? Yes. So it means the number 7 and all the numbers to the what of 7, left or right? Yeah, okay. On a number line, that's what I'm talking about right there, okay? Now that's a good visual. Now I need to go from here to interval notation, okay? So I look at the number line and it tells me, okay, what is the smallest number to the left that I can ever find here? Negative infinity. So this is negative infinity. And what's the largest number that I see shaded? 7, okay? What enclosures go around that? There's a bracket on the 7. What is always around infinity or negative infinity? Parentheses, okay? So to get from here, this column 2 to column 3, you just look at what's shaded. This number over here is negative infinity, so negative infinity to 7, okay? Now, let's just do another one, and I'm just making some of this up as I go. Let's make this, suppose that is the number 5, okay? How do I write over here using inequalities this situation? This means x is what? Greater than 5. What is the interval that goes from here to wherever that is? Yeah, 5 to infinity with what kind of enclosures? Parentheses on the 5 because you see that open circle, okay? And parentheses is always around infinity, okay? Let's look at the next one. We'll say negative 4 and 6, okay? Now, look at this situation here. If I write this as an inequality, it means x is what? Yeah, less than negative 4, or x is what? Greater than equal to 6, okay? Now, you look at this. How many intervals do you think that's going to be? Right here. So this, look at this shading here. This is one interval. That's another interval. How many intervals are there? 2 intervals. Okay. What's the first interval here? Negative infinity to negative 4. So negative infinity to negative 4. Always a parentheses on infinity or negative infinity. What kind of enclosure goes around negative 4? Parentheses. Okay. And what's this next interval? Yeah, bracket 6 to infinity. Okay. Now, there's another thing that happens mathematically. We just have a symbol, a big U right here. That just means or, okay? So U means or union. The reason it's or is like, is it possible for a number to be right here and here at the same time? Can a number be here and here at the same time? No. So that's why my solution, I've got numbers that are either here or they're over here. They cannot be in both places. Okay, that's why I get 2 intervals for that answer. Now let's look at one here. We'll say this is 5 and 12. Okay, so in inequality notation, how do I write this condition? All the numbers that are what? What are they relative to 5? These numbers are what? Bigger or smaller? Bigger. So I write greater than equal to 5 relative to 12. What are these numbers? Less than equal to 12. Now, does every number that you see meet both conditions? Yeah. So it's another way of saying it's x is greater than equal to 5 and x is less than equal to 12. Okay. Or you could write it this way. Okay. Yeah. So either way, you can write it like that. Now, how many intervals are shaded? No. When I say how many intervals, like there's only one. This has 2 intervals. 1 interval. This is 1. It's all the numbers between what? 5 and 12. What kind of enclosures? Brackets. Okay. You guys are good with that. Let's do this one. Same thing. 5 and 12. What's the interval notation for this one? Yeah, so so x is greater than equal to 5, and x is what? Less than 12? When I write this in interval notation, it's all the numbers from 5 to 12, but what enclosures? Yeah, bracket on the 5, parentheses on the 12. And then if I'm continuing on with this same problem, if that were 5 and 12, this is all the numbers that are what? Less than 12, greater than 5. And what's the interval here? 5, 12, and both of them have parentheses. Okay. Okay, you've done this, right? So let's start here where I give you the interval. Okay. How do I draw this on a number line? What number did I go find? -2. I don't care where you put it. Call it -2. What's going to go on the -2? An open circle or a closed circle? Closed circle. And where will I shade? To the left or right? Yeah, left. Okay. That's the number line. And then in inequality notation, this means what? Less than or equal to -2. Okay. And I go to this one. I go to the number line. I draw -2. And what kind of circle? Open circle, shade to the left, right? And this is what? X is what? Less than -2. And I think there are a couple more. -5, 2. When I go to the number line, I just draw those. Now, here's the key. When I'm drawing 2 numbers, does it matter which number is on the left and which number is on the right? What do I want on the left? The smaller number. So this is going to be -5. That's going to be 2. I don't care about, there's a 0, count over 2. I don't care about that. Just get the smallest number on the left, get the bigger number on the right. I don't care about how many tick marks are there, okay? What kind of circle goes on 2? Open, -5, close, shade in between, okay? So these are all the numbers that are less than 2 and what? Greater than or equal to -5. And the same thing here, -5, 2. And then at -5, I have what? An open circle. 2, I have a closed. And I shade where? In between. And in inequality, this is what? X is what? Greater than -5 and less than equal to 2. Okay. Now, when you see this, how many intervals have I just spelled out here? 2. When I draw the number line, how many different things are going to be shaded? 2. Okay. So I just need to find -5 and 5, okay? What kind of circle goes on -5? Open. What kind of circle goes on +5? Close. Then where do I shade? Yeah, I shade to the left of this one, and I shade to the right of that one, okay? So this means that looking at this one, how do I describe? This means x is what? Less than -5, or x is what? Greater than or equal to 5, okay? So let me take a pause here. Pardon me? This, that just means or. So that should have been a fairly easy warm-up and review of interval notation. Now, let's talk about the big thing that we have to be really careful of when we deal with inequalities, and that comes when we multiply or divide by a negative number. What happens to an inequality when you multiply or divide both sides by a negative number? It switches, okay? Now, why does that happen? So if we take just a moment, what's the relationship between 1 and 10? Which of those numbers is bigger? 10. So is that a true statement? 1 is less than 10. Now let's put negatives in front of everything. What's the relationship between -1 and -10? Which is smaller? -10 is smaller. Is that a true statement? Yes, okay. So you can tell by just putting negative signs what had to happen. Yeah, the inequality had to flip, okay? If I look at this on a number line, here's 1 and here's 10. If I look at these two numbers, here's -10, here's -1. So you can see what happens just by putting negative signs, the relative, which one's smaller, which one's bigger, changed, okay? Now that's the big thing you have to do when we're solving equations. Now, the only thing you could solve, if this were an equation, you would solve it by distributing, gathering your x's, gathering your numbers. We're going to do the very exact same thing here. We just have to be really careful. Anytime there's an inequality, know when you multiply or divide both sides by a negative, you got to switch the sign. Okay, so let's take this one and solve it. Okay, so -5 x minus 1 greater than equal to 6 minus x. Okay, what do you think is the first thing I'm going to do? Distribute, because I want to try to gather up all like terms. What's -5 times x? That's -5x. What's -5 times -1? Plus 5. Greater than equal to 6 minus x. Okay. Now I've got to get all my x's on one side and all the numbers on the other. What do you want to do? Add 1x to both sides? Okay. So if I add x to both sides, do I have to flip the inequality? No, that's only when I do what? Multiply or divide by a negative, okay? So what do I get here on the right? Excuse me, on the left I get what? -4x plus 5 greater than equal to 6, okay? Trying to get all the x's together, what do you think I would do next? Yeah, subtract 5 from both sides. And then that will give me -4x greater than equal to 1. What do I have to do now? Yeah, to get the x by itself, I've got to divide by -4. Now what I will always do, I will do this, okay? Why do you think I do that? I've got to remind myself that I just divided both sides of this thing by a negative number, and do not pass go or collect $200 until you flip that sign, okay? So what does the left side become? X. What does this thing remind me to do? Flip this. And what do I get when I take 1 divided by -4? -1/4, okay? That's the hard work. But I want your answer to be in what notation? Interval notation, okay? Now, you might be able to jump straight from here to interval notation. If you can't, the number line is there to help you. How would I draw this on a number line? What number will I draw? -1/4. Will it be an open circle or a closed circle? Will I shade to the left or the right? Okay. How many intervals is that? That's one interval. What is that interval? -infinity up to -1/4. What goes around the -1/4? What goes around infinity? Always a parentheses. Now, that's my final answer. This is what I want the answer to this problem to be. But you can see algebraically, this is how the algebra worked out. This is not a required step, but does it help you visualize it? So that's just up to you. So on the test, there might be a number line there, or it might suggest you do a number line, or there may not be a number line. You need to know that when you see this, a number line can be a helpful way to get from here to the interval notation. Okay? So this rings a bell. You've done something like this before, right? Let's take a look at this one. -3x plus 1 is greater than -8. My goal is to get what on one side? All the x's on one side, all the numbers on the other. What's the first thing I'm going to do here? Subtract 1 from both sides. This gives me -3x greater than -9. What's the next thing I'm going to do? Yeah, I'm going to divide by -3, and the bells are going off in your head because what? You have just divided both sides of inequality by a negative number. So I'm going to circle that because that reminds me I got to do something. What do I get on the left? On the left I get x. What happens to that greater than becomes what? Less than. What's -9 divided by -3? Yeah. So the answer here is, well, not the answer. X is less than -3 is the condition. I want this to be in what notation? Interval. What is interval notation on this one? -infinity to 3. So if you can jump from here to here, I'm fine with that, okay? But if you can't, you know, or if it just helps you to do this, okay, that means 3, open circle, shade to the left. If it helps you to do that visual, it is certainly fine to do that, okay? Yes. No, you do not have to, okay? I just put it there as like it can, where people run into trouble is when they get something like x is less than 3 and x is greater than equal to 5. Sometimes people have trouble going straight to interval notation. So in that case, you'll find that the number line can be helpful. So that's why I put this on all the problems just out there. So at the end of this lesson, here's what we did today. You're familiar with less than, equal to, greater than equal to. What we have solved are simple inequalities. By simple, the problem has one inequality. So something like that's a simple inequality because only one inequality. What we're going to deal with next time is something like that's a compound inequality because it has how many? It has more than one. It's got two different inequalities. So this is not what we're doing. So simple inequality means there's one less than, greater than, less than, equal to, greater than, equal to. You know to change the sign, to change the inequality when you divide or multiply by what? Negative number. You understand the parentheses and the brackets in interval notation, and you understand on the number line the difference between the open circle and closed circles, okay? So it's just like all of these were solving just like linear equations, except they had inequalities, and you had to be careful when you divide or multiply by a negative number.